Welcome, travelers, to Adventures in Security. This is the sixth in a series of videos that describe the CISA Zero Trust Maturity Model, addressing the fifth pillar, the data pillar. The paper on which this series is based is available at a link in the video description. If you like what you see, if you learn anything, please remember to give us a thumbs up and subscribe so you don't miss future content. Databases sit at the heart of the Zero Trust Maturity Model's data pillar because, unlike files that can be copied and carried away, tables, views, and logs are usually accessed through predictable query paths that lend themselves to continuous verification. In a traditional environment, the database server is placed on a trusted subnet, shares a single service account for many applications, and depends on perimeter firewalls to keep outsiders out. If an attacker reuses a stolen credential or pivots laterally from a compromised host, the server has little context to challenge the request. Sensitive rows are protected only by coarse role-based privileges, and encryption at rest, if enabled at all, uses static keys that seldom rotate. The initial stage brings the first elements of data-centric control inside the engine. Security teams automate a data inventory, label highly sensitive tables, for example, a PII or financial reporting, and activate column-level or transparent database encryption keyed by an enterprise secret management service. Attribute-based access control, ABAC, overlays the legacy roles, requiring a user to present both the correct role and the contextual attributes, such as shift time or device health, before a query proceeds, thereby reducing exposure if a single factor is compromised or stolen. Database activity monitoring sensors feed these decisions into the organization's analytics pipeline, providing operators with their first real-time view of who touches which record. In the advanced stage, a database embraces the never trust, always verify mantra at query speed. Every request passes through a policy engine that evaluates row-level labels, the risk score of the caller's identity, the client's geolocation, and even the application binary's code-signing hash. Keys rotate automatically, and the engine applies dynamic data masking so that an analyst browsing a customer table sees only the fields their task demands. Continuous telemetry from the activity monitoring agent streams into the SIM. If machine learning models identify unusual access patterns, such as a clerk suddenly pulling an entire credit card table, the policy engine can block or quarantine the session in seconds. In the optimal state, the database becomes self-defending. Confidential computing extensions keep data encrypted even while it is processed, eliminating the brief in the clear window that attackers exploit. Fine-grained labels are applied in real time as new columns are added, and artificial intelligence classifiers adjust those labels when data drifts out of its original sensitivity category. The same analytics that drive adaptive identity or device decisions now revoke decryption keys or shard a table across trust boundaries. Backup copies inherit the same policies, so restoring a snapshot never reopens yesterday's vulnerabilities. Taken together, these measures satisfy CISA's expectation that protection follows the data, not the server. Hence, an adversary who reaches the database interface still needs to fulfill a chain of real-time checks before being able to view a single row. Recent NIST reference builds demonstrate that enterprises adopting automated labeling and ABAC at the initial stage cut mean time to detect insider misuse by more than 40%, laying the foundation for the analytics-heavy controls required at advanced and optimal levels. That's it for this video. If you have questions or comments, post those in the video discussion. And until next time, be careful what you click.